So, hello everyone. So, this is a question from LeetCode. We have to calculate if a number exists in power of 2. Okay. Uh, just suppose let's take an example. Yeah. So, just a simple example. Okay. So, in this question, we are asking if a number is exists in 2 to the power or it's not a 2's power, right? Suppose if number is 4, then we can write it 2 to the 2 uh, 2 power 2, it is equal to 4, right? And suppose if number is 10, then we cannot write in 10 in the form of 2's power, right? So it will be false. In this case, the if number is 2's power, then we have to return true. If the number is not in 2's power, we have to return the false, right? So there could be the multiple ways for solving this problem, but yeah, let's do a simple one and the fast one. I assume that you are aware of the bit. Okay, so suppose for if I write a number of one, then for one we can write in between 0 1, right? For two we can write it 1 0. For three the bit is 1 and 1, right? And for 4 it would be 4000 1000, right? So if you can see, just examine this bit very carefully. If you can see now, if any number exists in 2's power, then the most significant bit, we can also say it most right bit will be set bit, okay. The if the bit is 0, then is when bit is 1, then we also called it set bit, right? And when the bit is 0, we also called it 0 bit or 0 bit or unset bit. So for every number, if a number exists in 2's power, then we can say the most significant bit means the last bit means most significant, the last left bit, the first bit we can say from left, it could be the set bit, and the rest of all others would be the unset bit, that means 0 bit. In the case of 2, you can see for the 2 we can write it one in bit format, 1 and 0. Then the most significant bit, that is most first bit from left, is set bit, and all other are unset bit, right? uh, if you see in the case of 4, the most significant bit is set bit and all other are 0 bit, right? If you write for 6, if you write for 5, then it will be 101, right? You can see here there are two set bit. Okay, if a number is exist in 2's power, then it only contain only one set bit, and this one set bit would be the right right bit, or we can also say the most significant bit. Okay. If you can take the example of 8. Okay, for 8 we can write it 100 100 and 0, right? In this you can say the most significant bit is 1, and this contain only one set bit, right? Suppose if I multiply, okay, so tell me the set the bit format of number 7. It will be what? It will be 0 1 1 1. Okay. In this case, if I want to do, if I do the AND method, AND function for number 8 and 7, what you will get? We will get 0 0 0 and 0, right? For 1 and this 0, it could be it would be 0. This 0 and this one, it's 0. This one. So what I'm trying to explain you, basically, in every, if a number, if a number exists in twos format, and and if you do the and operation with one lesser number of that number, we will get all bit to 0. You can try any one of them. Suppose let's take 4. For 4, we know the bit format is 100, and if you do and format and logic bit with 3, we will get for 3 the bit format is 0 1 1, right? uh, Their and format, what we will get? 0 1 0, 0 and 1 0, 0 and 1 0. Okay, so are you getting my point? Just what I'm trying to do, if the any number, if a number is 4, we will do the and format with number 3. Okay, if it is equal to 0, that means our current number, that means our number, our number is 2's power, 2's power, in the form of 2's power. We can write that number in 2's power, right? Let's do for 5. Let's check if 5 is we can write 5 in 2's format or not. Then what I will do in this logic, I will do the AND operation with one lesser number, that is 4. Okay, what we will get? So for 5, the uh, the bit format for 5 number is 101. Okay, and for 4 is 100, right? When we do the AND format, we will get 1 and 1 1, and 0 and 0 0, and then again 1 0 1 1 0 0. Then it is not equal to 0, not equal to 0. We can say 5 is not the 5 is not 2's power. Okay, let's try to code it. So what I have seen, uh, if we'll calculate the number, if y is equal to what, n, we will do XOR operation with n and n minus 1, and we'll check if what, if bell is equal to 0, that's it, that means we can write it in the form of 2's power. We can write it true. Okay, else we will write false. Okay, yeah. But one more test case you should remember. If the number we should handle for the number 0, if number is 0, we can write it directly false. So, okay, so what we can write it in one line, return what, n greater than 0, and uh, n greater than 0, and n with and operation n minus 1. If it is 0, what, if it is 0, that's it. If n is 0, that will, this will return the true, it else it will return the false. Okay. Let's give it a run. Yeah. Oh, it's giving the expected result. Let's try it. Let's try to submit it. Yeah, it's submitted successfully. Yeah, thank you. Let's meet in the next video.